Hey guys, it's Bruno, the IB Math teacher. So welcome to week number 9. First of all, we're very close to the end. We have less than 2 weeks to your IB Math exams. Hopefully this challenge has been productive or helpful for you. In this Ace Your IB Math exams in 10 weeks challenge, we go through 5 different questions in all 5 topics in IB Math, and we solve these exercises together. They're very mixed. There are paper 1, paper 2 questions, there are easier ones, there are harder ones. This is a way for us to mimic your IB Math exam, which is around the corner, okay? So let's get through week number 9 now. If you've missed anything, you can find all links and all resources in the description of this video. And do share these resources with your colleagues so you guys can study together. And let's get to it. Let's get through week number 9. So we have a system of equations, and these two equations involve logs and exponentials. Now, this can be misleading in the sense that it doesn't look that complicated, but let's see if that's actually the case. So we have two equations, equation 1 and equation 2. I'm going to label them right here. And the idea here is to do a substitution, but before we can do that, we need to work with them a little bit. We can start with equation number 2. 3 to the ln of x is equal to 2 to the ln of y. Now, the only way for us to drop these exponents is to evaluate the lateral ln of both sides. So we're going to do ln of 3 to the ln of x equals ln of 2 to the ln of y. And using exponent rules, we can write this as ln of x times ln of 3 equals ln of y times ln of 2. Which means finally that you can rewrite ln of y as ln of x times ln of 3 over ln of 2. Now let's move to equation number 1, and similarly we're going to evaluate the ln of both sides. By the way, you can rewrite this to ln of 2 as ln of 4, which means that this can turn into this. And by using ln on both sides, using a similar strategy to the one that we used before, we get ln of 4 times ln of 2x equals ln of 3 times ln of 3y. And again, using log properties, we have ln of 4 times ln of 2 plus ln of x equal to ln of 3 times ln of 3 plus ln of y. Now we know that ln of y can be written like this from the second equation. Therefore, we have our left-hand side equal to ln of 3 times ln of 3 plus ln of x times ln of 3 over ln of 2. Now we're kind of like halfway through there, so let's continue foiling. Ln of 4 times ln of 2 plus ln of 4 times ln of x equal to ln of 3 squared plus ln of x times ln of 3 squared, all of that over ln of 2. Now we're going to move every term that has x or ln of x to the left-hand side, and every term that does not to the right one. Ln of 4 ln of x minus ln of x ln of 3 squared over ln of 2 equal to ln of 3 squared minus ln of 4 ln of 2. Now putting ln of x as a common factor, we have ln of 4 minus ln of 3 squared over ln of 2, which is equal to ln of 3 squared minus ln of 4 times ln of 2. Now when you get to this in an IB exam, you're probably thinking about giving up or that something is off. But trust me, we're going to get some friendly numbers as results. Let's just continue. Dividing both sides by ln of 4 minus ln of 3 squared over ln of 2, we get ln of 3 squared minus ln of 4 times ln of 2 over ln of 4 minus ln of 3 squared over ln of 2. We can write the denominator as ln of 4 times ln of 2 minus ln of 3 squared, everything over ln of 2. And in the numerator, we get ln of 3 squared minus ln of 4 times ln of 2, which means that we can simplify lots of terms. By the way, there's a square here. I don't know what happened to it, but it should be here. Now, these terms that we can simplify are these, but do be careful because this simplification leads to -1. Do notice that this is equal to this times -1, or the other way around, of course. So we get ln of x equal to negative ln of 2, which means that ln of x is ln of 2 to the -1, also known as 1 over 2. Therefore, x is equal to 1 over 2. So kind of a friendly result. In order to find y, we can replace x into this equation that we found before. So this is ln of 1 over 2, which is the same as negative ln of 2 times ln of 3 over ln of 2, which is equal to negative ln of 3. Now, if ln of y is equal to negative ln of 3, then ln of y is equal to ln of 3 to the negative 1. Therefore, y is 1 over 3. All right, so let's start exercise number 2, one which involves functions, more specifically logarithmic function, a logarithmic function, transformations, inverse functions, the whole 9 yards. Okay, so let's get to it. The function f is defined by negative ln of 3 times x plus 1. We can already see that using ln of x as a reference, as a parent function, we have 3 transformations being applied to this function f of x, or apply to the parent function to get f of x. What are these transformations? We have this horizontal shift 1 unit to the left, and by the way, I'm not specifying these transformations in any specific order. We have a horizontal compression by a scale factor of 3. Although we don't use the word compression in IB math, it doesn't look quite good. So what we say is we have a horizontal stretch by a scale factor of 1 over 3. And also we have a reflection across the x-axis, which is represented by this negative sign right here. The negative makes all the values of the range flip sign, so we get the opposite of what we had originally. But we're going to talk about these transformations in a minute. First of all, we need to find the coordinates of the points, or the exact coordinates of the points where the graph of f of x crosses the x and the y axes, meaning the x and the y intercept. We know that to find y-intercept, or the y-intercept, we replace x by 0, meaning we calculate f of 0, which means negative ln of 3 times 0 plus 1, which is negative ln of 3. And to find the x-intercept, we replace y by 0, or in this case, f of x by 0. So we have 0 equals negative ln of 3 times x plus 1. We can multiply both sides by negative 1, which gives us 0 equal to ln of 3 times x plus 1, which means, and this is a property, the conversion between exponentials and logarithms, when we have log of a base b equal to c, this means that a is b to the c. Therefore, and given that we have a base e over here, this is the same as log base e, we have 3 times x plus 1 equal to e to the 0. And given that e to the 0 is 1, we have x plus 1 equal to 1 over 3. Therefore, x equals negative 2 over 3. So the points are 0, negative ln of 3, and negative 2/3, comma 0. All right, so let's move to exercise B now, the one with the transformations. And I'm going to be careful here to state the transformations in order. Remember that all transformations in x which impact the x values, they come first, and then all of the transformations in y, they come later. And within these transformations in x, stretches, compressions, and reflections, they come before translations, before shifts. And the same thing happens to the transformations in y. Stretches and reflections, they come before shifts or translations. Which means that in the appropriate order, this 3 over here is the first transformation that we should address, that we should state. In this case, we have a horizontal stretch by a scale factor of 1 over 3. Remember that in IB, you don't state compressions as compressions, despite the fact that they look like compressions. You state them whenever they impact the x values as stretches by a scale factor of 1 over the multiple that you have in front of you. So in this case, 3. So 1 over 3. And then we have the last transformation in x, which is this plus 1. So a horizontal shift 1 unit to the left. And lastly, we have this negative sign over here, which represents a reflection across the x-axis. And there we have it. Now, with this in mind, we're going to sketch this curve starting from the parent function. And what is the parent function? The parent function is ln of x. So let's call p of x our parent function, which is ln of x. We're going to start with that. I'm going to draw it using a dotted line, so we have it as a reference. It has a vertical asymptote at x equals 0. And by the way, yes, you should know how the graph of ln of x is. It crosses the x-axis at 1. And let me write the asymptote right here. So what happens to it? First of all, we have this horizontal stretch by a scale factor of 1/3, which is going to compress the curve So instead of going through the point 1 comma 0, it is going to go through the point 1/3 comma 0. Therefore, it will look something like this. And again, this is not the final answer. This is just the curve of ln of 3x, the first transformation being applied. So this point is 1/3 comma 0. Now let's apply the second transformation, which is to shift this graph 1 unit to the left. If we're moving 1 unit to the left, this 1/3 will be -2/3. And the vertical asymptote, which was x equals 0, will move to x equals -1. So there we go. So this is ln of 3 times x plus 1. Now on to the last transformation, which is the reflection about the x-axis, which is now indeed the graph of f of x. Reflecting about the x-axis will not change the vertical asymptote. It is still at x equals -1. However, the curve itself will be reflected about the x-axis as mentioned. Notice that we already knew that this graph would cross the point -2/3 comma 0. That's what we did in exercise A. Also, the y-intercept over here is -ln of 3. So there we have it. This is the sketch of the graph of f of x. All right, so let's jump to question D. We need to find the inverse of f. How do we find inverse of functions or inverse functions? We first flip the x and the y's. We exchange the y for x, and the x's, all the x's that show up for y's. We only have one x over here, so what we're going to have is x equals -ln of 3 times y plus 1. We may move the negative sign to the left-hand side, so we have ln of 3 y plus 1, positive ln of 3 times y plus 1. Then applying the exponent and log property, the conversion, we have 3 times y plus 1 equals e to the negative x, which means that y plus 1 is equal to 1/3 of e to the negative x. Therefore, y equals 1/3 e to the negative x minus 1. However, we should write the inverse function with f -1 of x. Therefore, the final answer over here, or for this exercise, is f -1 of x. So the inverse of f equals 1/3 e to the negative x minus 1. And what is the domain of this inverse function? Well, it's the same as the range of the original. The range of the original is all real numbers, but we can see that the domain of this function, there's no restriction here, so it's all real numbers. However, the range of the inverse, which is the domain of the original, well, it goes from -1 to positive infinity. Therefore, y has to be greater than -1. And that's it. Exercise number 3, a tricky trig question, one that involves a trig identity, which I know belongs to HL math. However, in this case, we're using something that's given, sine of a plus b and cosine of a plus b, in order to prove tangent of a plus b. So this is a very nice trig proof, one that's complex, not simple. And we're going to use that identity on question B. So a very interesting exercise. Let's get to it. Given that sine of a plus b is sine a cos b plus sine b cosine a, again, this is from the HL portion of the formula booklet, and given that cosine of a plus b is this, show that this is the tangent of a plus b. Now, one thing that you can say that you need to know actually is that tangent is sine over cos. So that's exactly how we're going to start. Given that tan is sine over cos, tangent of a plus b is equal to the sine of a plus b over the cosine of a plus b. Now from here, we're going to replace the identities. We're going to substitute the identity. Sine a cos b plus sine b cos of a over cos a cos b minus sine a sine b. Now it is worth taking a sneak peek at the answer at where we're trying to get. We're trying to get to tangent of a plus tangent of b over 1 minus tan a tan b. Therefore, using this as a hint, maybe it's a good idea to divide both the numerator and denominator by cosine of a times cosine of b. And why is that? Well, if you do so and you can divide them individually or everything, it works the same way. You get the one that you were looking for over here in this position over here. And also, if you check this tangent of a, do notice that that's exactly what you get over here. So let's divide everything by cos a cos b. We simplify these. We simplify everything over here, which gives us 1. And over here we have 10 of A times the tangent of B. Remember that this is tangent of B. Therefore, we get just that. 10A plus 10B, 1 minus 10A times 10B. Now, question A is done. Let's jump to question B now. Find the tangent of alpha. Let me start by finding the tangent of theta, which we're going to use for question C. Now, if you check this square right here and this diagonal, you can see that tangent of theta is opposite over adjacent, meaning this side over this one, which is the same. Now tangent of theta is equal to 1. We know that this angle is 45 degrees or pi over 4, but we don't actually have to write that. Now that's the same thing, or similarly, we can do roughly the same thing for this rectangle here. Now we have a rectangle with this diagonal here, where the base is 2x and the height is x. So we know that tangent of alpha now is opposite over adjacent. Therefore, tangent of alpha is 1 over 2. Now for question C, we're going to use this identity to show that tangent of alpha plus beta is equal to tangent of theta, meaning we're going to replace A by alpha and B by beta. So we have tangent of alpha plus beta equal to tangent of alpha plus tangent of beta, which we can find as well, 1 minus. Before we can replace these values, so we have tangent of alpha, which is 1 over 2, plus tangent of beta, which is 1 over 3, 1 minus half times 1 over 3. So we have 5 over 6 over 5 over 6, which is equal to 1, which is equal to the tangent of theta, which we found before. So that's it for exercise number 3. All right, so on to a probability question that might look a bit confusing, so hopefully we get to clear things up right now. So here's the situation. Hinata goes to school every weekday, so 5 days a week. On any day, the probability of her missing the train is 2 over 7, something that we can already fill out in our diagram. So missing the train is 2 over 7, therefore, given that the sum of this should be 1, the sum of these two, this is 5 over 7, which is the probability of not missing the train. If she misses the train, the probability of her being late is 5 over 6. So missing means that the probability of being late is 5 over 6. Therefore, the probability of not being late when she misses the train is 1 over 6. Again, the sum must be equal to 1. And if she does not, the probability of being late is 1 over 10. So 1 over 10 and 9 over 10. So we are done with question A. Now, given that in one specific day she was late, find the probability that she misses the train. This is a conditional probability. The probability of A given B is equal to the probability of A and B over P of B. In this case, the probability that she missed the train given that she was late, that is equal to the probability of missing the train and being late over the probability of being late. Now, we can color code this, and the probability of missing and being late is this times this, so 2 over 7 times 5 over 6. We multiply these probabilities to get the probability of missing the train and being late, which gives us 5 over 21. Now on to the probability of being late. She's late if she misses the train and she's late, which we found already, or she does not, but still she gets there late. So that means 2 over 7 times 5 over 6, which we know is equal to 5 over 21, or which means plus 5 over 7 times 1 over 10, which is equal to 13 over 42. And we get 5 over 21 over 13 over 42, which gives us 10 over 13. All right, so we're done with question C. Now on to the most interesting one. Hinata always knows before leaving home whether she'll make it to the train station on time. So let's say that she's at home. Let's call this home. And let's say that she looks at the clock and she knows whether she's going to make it on time or not. She knows how long it takes to get to the train station. If she knows she's going to miss the train, then at home she calls an app, or she uses a ride-sharing app, and she spends $18 to get to school. However, if she believes she can make it on time, then she takes the train. But upon arrival, two things might happen. She gets to the train station near school and she's still late, so she needs to call or use a ride-sharing app, which costs $6, or she did get on time using the train and she just walks to school. Knowing that the train ride itself costs $3, how much on average does she spend weekly to get to school? Now let's break this down into three possibilities. She's getting dressed and then she looks at the clock and she's gonna be late for sure. Therefore, in that case, which involves the probability 2/7 to occur, this possibility here will cost her $18. However, there are other two possibilities. Number one, she did catch the bus, but maybe, the train, but maybe the train was too slow and she needs to use an app, which will cost her. All right, so on to the most interesting part, which is question C. Renata decides how to travel based on whether she will miss the train. What does that mean? It means that she's going to consider different options according to whether she can catch the train or not. If she knows she'll miss the train, let's say she's getting dressed, for example, at home and she runs late. So she knows she's not going to be able to take the train. She takes a direct ride to school using a transportation app, which costs $18. What this means is if she misses the train, this will cost her $18. And if she catches the train, well, we have two different options here. She can still be late or not. Catching the train costs $3, and the probability associated to it is 5/7, by the way. If she is still running late, she will need to pay an additional $6 because, well, she needs to use the transportation app to go from the train station to school. Now, if she's not, she can just walk to school, which is the second option right here. So let's consider these different paths. We have a probability of 2/7 that she misses the train, or 5/7 times 1/10 that she does not miss the train, but still she is late. Or third option, she does not miss the train and she's not late. And to find the expected value of the cost, we are multiplying each probability by the cost associated to it. So in this case, for example, 2/7 costs $18. 5/7 times 1/10 will cost $9, which is the train ride plus the transportation app ride, which is $6, or only the cost of the train ride, which is $3. So each weekday, she will spend in average $7.71. Therefore, in 5 weekdays, in average, she spends $38.57. All right, so for exercise number 5, a calculus question as usual. We have an optimization problem here. Ayla is producing the packaging of these caramelized peanuts. And this cone-shaped packaging is produced by removing a small sector from a circle with radius 12, as the image indicates. Now, the first thing that we can do here is to draw the cone. So this is how the packaging looks like. We have a radius of r. Now, this 12 over here is the slant height of this cone. And it's easy to see that that is the case if you take, for example, this circle over here and you chop off a sector from it. So the 12, it is right here. That's the radius of this circle right here. Now, if we cut it off, and this is not gonna look super pretty because I did this in like 15 seconds, we will get this cone right here. So there's the 12. Now that is 12. This is h, which by the way can be found right here as well. And this is r. Therefore, given that the volume is 1/3 pi r squared times h, and given that what we need to show does not include any h in it, we gotta find h as a function of r first. So consider this right triangle. We have 144, the hypotenuse squared, equal to r squared plus h squared. Therefore, h squared, which is 144 minus r squared, h is positive and negative, but it doesn't make sense to have a negative value. It is positive 144 minus r squared. Therefore, we have our height as a function of the radius. So our volume is indeed 1/3 pi r squared times the root of 144 minus r squared. What's harder in this exercise is to identify the fact that this 12 is the slant height. Everything else is just fine. Now let's jump to question B. Find dv dr, which means the derivative of the volume with respect to the radius. Now this is the volume. 1/3 and pi, these are just constants. What we actually need to differentiate here is r squared root of 144 minus r squared. And for this, we need to use the product rule. Let's call u or r squared, which means that du is 2r. Let's say that v is the root of 144 minus r squared, which by the way can be rewritten as 144 minus r squared to the half. By using the chain rule, we have the derivative of this root, so 1/2, 144 minus r squared to the negative half, times the derivative of 144 minus r squared, which is negative 2r. Therefore, dv, it is equal to negative r over 144 minus r squared inside a square root. The minus makes us drop the root to the denominator, and 1/2 means root. So that's why we have this as dv. So continuing, we have 1/3 times pi, u times dv, plus du times v. And if we use the root as a common denominator, which means multiplying this and the denominator by root of 144 minus r squared, we get negative r cubed plus 2r times root of 144 minus r squared squared, which means that the root is now gone. So we have 288r minus 3r cubed in the numerator and the root in the denominator. And by the way, we can simplify this even further by dividing this by 3, which gives us pi times 96r minus r cubed over the root of 144 minus r squared. And now, in order to maximize the volume, we are going to take this dv dr and make it equal to 0. That's how we find maxes and mins. And in this case, we're going to find the max. If dv dr needs to be equal to 0, that means that pi, 96r minus r cubed over the root, it's got to be equal to 0. Now, if we cross multiply this root, and we can do the same with the pi by dividing by 0, or actually dividing 0 by pi, we just get 0 on the right hand side, and all that we have left is the 96r minus r cubed that we have in the numerator here. We can factor out an r and break this down into two. Either r is 0, which does not make sense with the context of this problem, or 96 minus r squared is equal to 0, which means that r squared is 96 and r is positive. It's got to be positive. The root of 96, also known as 4 root of 6. Now we're almost done. If this radius right here is 4 root 6, that means that this circumference, which by the way is the same as this, it is equal to 2 pi times the radius, so 2 pi r. Careful not to use this as the radius, it's this radius right here, because we're not finding this circumference, we're finding only from here to here, which is equivalent to this. So we get 2 pi times 4 root 6, which is 8 pi root 6. Therefore, this arc length right here is 2 pi times this radius, which is the whole thing, minus the green portion. And we know that arc length is theta, which is this angle right here, times the radius, which in this case, it's 12. So theta times 12 equals, and let me move this here, 2 pi times 12 minus 8 pi root of 6. We can divide everything by 4, so we get 6 pi minus 2 pi root 6, which means that theta is 6 pi minus 2 pi root of 6 over 3, which can also be written as 2 pi minus 2 pi root 6 over 3 radians. And that is it. An exercise that's way more complicated than what it looks initially, especially due to the geometry of the problem. All right, week number 9 is done. We just have one more to go. I'll see you next week. Keep strong, be strong, stay strong, and I'll see you in 7 days. Take care.